Okay, this is Algebra 2. We are in day 3 of quadratics and we're looking at transformations. Let's start by reviewing what you've already learned. The vertex of a quadratic function is the place where it changes directions. It's going to be either a low or a high spot on the graph. The x-intercept is called a root, a solution, an answer, or all of the above. And that's going to be all of the above. They can all mean the same thing. So here's a parabola with an x-intercept of -1, 0 and an axis of symmetry at x equal 1. What are the coordinates of the other x-intercept? So they've already given you -1, 0, so the other one is going to be at 3, 0. That is another x-intercept, another solution, another root. Is the vertex a maximum or a minimum? It's up high. This is your vertex. That makes it a maximum. How many roots do you have? This is asking how many times it crosses the x-axis. 1, 2. So there are 2 roots. What is the domain? There are no points at the end, so you have to assume that these are arrows. That means that your domain is ARN. The only time your domain is not ARN is if they give you definite points showing the beginning and the ending of the line. What is the range? 2 ways you can do it. You can go with the fact that it opens down, and so y has to be less than or equal to a number, and it's going to be the y that it's the highest point at, which is 4. Or you can do like we learned when we learned domain and range, and you go from bottom to top. Bottom, it's going forever, so I don't put a number, so y is less than or equal to, and then the highest it ever gets is 4. You get the same answer either way. What is the y-intercept? Y-intercept is where it crosses the y-axis, and so it would be 0, 3. What is the vertex? It's the point where it changes directions, so that would be 1, 4. It's written as a point. What is the axis of symmetry? Axis of symmetry must have x equal, or I will count it wrong. It's x equal to the x value of your vertex. So it's this line here that kind of cuts your graph in half. So it's x equal 1. The quadratic term, 3x squared. The constant, -6. The linear term, +5x. Quadratic term, x squared. Linear term, -3x. Domain, they gave you an equation, so it has to be ARN. The range, you would have to put this in and look at it on your calculator. Clear it out. We have x squared minus 3x. Look at your graph. And so you're going to have to figure out what your min is. Second, calc, 3 for minimum. Enter, go to the right until you get past it. Enter, enter. Your vertex is 1.5, -2.25. So -2.25 is what you're dealing with. And if you looked at your graph, you noticed that it opened up, so y is greater than or equal to. All right, so now looking at your worksheet. We're talking about transformations, we're talking about changes. We discussed transformations in depth at the beginning of the year. The rules are the same regardless of what kind of function it is, and so this should not be new stuff. Okay, so looking at this, they want you to state if there is a reflection. They want you to identify a vertical or horizontal shift and vertical stretch or compression, and then sketch a graph. So you've got to remember that the reflection over the x-axis would be caused by a negative at the front of the entire problem. A vertical shift is plus or minus a number at the end. A horizontal shift is plus or minus a number trapped with parentheses, or trapped with the x in your parentheses. A vertical stretch or compression is going to be a number at the front, and sketching it, you're just going to use all the changes and then figure out how to draw your graph. The transformations are listed on the wall. You should have note cards, you should have notes. This is not new stuff. So the first thing is there reflection over the x-axis? Is there a negative at the beginning? And there's not, so there is no reflection. Is there a vertical shift? Did it have plus or minus a number at the end? Yes, it had a plus 4, so it went up 4. All you have to write is up 4. Horizontal shift, was there anything trapped in there with the x? Yes, -2. Remember, horizontal movements do the opposite of what you would expect, so x minus 2 means it actually goes to the right 2. And then a stretch or a compression is a number at the very beginning, and there's not one. So you've got to take your parent function, and it's got to go up 4 and to the right 2. And when you did that, it would look something like this red line. Your parent function is the one that's going through the origin. So number 2, did we have a reflection over the x-axis? Yes, we did, because there was a negative at the front. Did we have a vertical shift? Yes, we did. There's a -5 at the end, and that sent it down 5. Do we have a horizontal shift? Yes, there's something trapped with the x, and so it's going to go to the right 4. And then was there a stretch or compression? And no, because there was not a number at the beginning. So this one is going to flip and open the other direction. It's going to go, the vertex will go down 5 and to the right 4. So you had to go down 5 over 4, and then it had to open the other direction. There is not a negative at the front, so there's no reflection. -4 at the end sends it down 4. +3 trapped sends it to the left 3. There's a number at the front, so it's a vertical compression, or vertical stretch by 2. Okay, so you're gonna take your vertex down 4, left 3, and a stretch is going to make it narrow. So down 4, left 3, and it's more narrow. There is no negative at the front, so there's no reflection. There's no number at the end, so there's no vertical shift. +5 sends it to the left 5, and 1/2 is a vertical compression, so that means it's going to get wide. So your vertex goes to the left 5, and the graph is wide. Left 5, wide graph. Use the transformations and the vertex form to determine a function rule for the quadratic graph. So what's happening here is they give you a graph, and you've got to tell us what happened. Okay, it's opening the other direction, so it does reflect over the x-axis. The vertex went up 1, 2, 3, 4, 5. The vertex went to the right 1, 2, 3. If it goes over 1 and down 1 and hits the line, then there was no vertical stretch or compression. And what else were we looking for? Oh, they're ready for you to write the equation. Okay, so that up 5 is going to be +5 at the end. That right 3 is going to make it x minus 3. And that should be your only changes that happen. So it should be y is equal to x minus 3 quantity squared plus 5. X minus 3 quantity squared plus 5. Okay, so my vertex went 1, 2, 3, 4, 5 to the left. It did not flip. There was no reflection. It went 4 down and 5 to the left. It does have a vertical compression. The reason I know that is I go over 1 and I only go up 1/2. Okay, I'm not going to be stressed if you don't get the exact right fraction, but you need to show me that there was a compression. So then it is ready for you to write your equation. 4 down means -4 at the end, 5 left means x plus, and then that 1/2 has to go at the front. So this is what I'm looking for your answer. 1/2 times x plus 5 quantity squared minus 4. You take that by building it, by finding all of your clues in your graph. And I can't remember if I highlighted that and pointed out that it is a negative at the beginning because of this reflection. So these are your 2 equations that you come up from looking at the graph. So this worksheet is what your assignment is going to look like. And I believe you are ready to begin that assignment. If you have any questions, call me over.